Hello, and welcome back for some more algebra fun with Mr. McFarlane. This is Chapter 2, Section 9, Weighted Averages and Mixture Problems. Let's talk about weighted averages first. If you look at the book, this is the definition it has. The weighted average M of a set of data is the sum of the product of the number of units and the value per units divided by the sum of the number of units. I don't see why anybody has a problem with that. But let's break this down a little bit because I find it a little slightly complicated. So let's look at what they call the slugging average in baseball. So when a batter hits a base hit, they calculate this based on how many bases he gets. So if he gets the first base, second base, third base, or whether it's a home run. So the slugging average is calculated for every hit that he takes and what he got, how many bases he got from that hit. Now, first base just gives him 1 point. Second base will give him 2 points. So I can't just calculate every at-bat. I have to calculate them slightly differently. So their slugging average is a weighted average where every one of the different hits has a different weight. Like a home run would be calculated 4 times. And the entire thing is divided by how many at-bats. So it's a little bit like calculating an average, but every one of these is weighted. This would be weighted 4 times for home runs, 3 times for third base, 2 times for second base, and just once for base. That's a weighted average. Here we have a problem. It took Travis and Tony 40 minutes to skate 5 miles. The return trip took them 30 minutes. What was the average speed for the trip? Now, I can't just find the average for each going there, which would be the rate is distance over time, 5 miles, and we've changed the minutes to hours because we're looking for average speed, that's in miles per hour, and the return trip. If I take these two, 7.5 and 10.5, and just try to average them out, I don't get an exact measurement because the distance, how long it took them to go there was 40 minutes. They came back 30 minutes. This was slightly, we're measuring different things here. So we'd have to find the rate of going times the time of going. This is a weighted average, plus the rate of the return times the time of the return, divided by time of going and time of return. Okay, sounds pretty complicated. There's another way that you can work this out, and that is just take the total distance. Sometimes this works, so we can figure out what's the total distance divided by the total time. So we could say their total distance, they went 5 miles there. The return, that's also going to be 5 miles. So 5 plus 5, going and returning, and then over the total time, 40 plus the 30. It's probably a whole lot easier for you to do it this way around, divided by 70. So there we would, and this is the rate in minutes. Now we'd have to just, we could divide the 70 by 60 to get hours. So that's 10 divided by 70 divided by 60 would give me 1.16 approximately, or 1.67. Divide that and you get approximately 8.6. Alright, let's look at some mixture problems. Okay, here we have a tea company sells a blended tea for $25 a pound to make blackberry tea. Dried blackberries cost $10.50 a pound and are blended with black tea that costs $35 a pound. How many pounds of black tea should be added to 5 pounds of dried blackberries to make blackberry tea? Well, we have 3 different things here. We've got the blended tea, so the blackberry tea. We've got dried blackberries, and we have black tea. Okay, we're going to mix the dried blackberries and the black tea to make blackberry tea. When we have a mixture problem like this, it's best to set up a table. Here we have the dried blackberries, black tea, blackberry tea. Okay, now you're going to set up several columns. Usually there's going to be a 3 by 3. The amount, the cost, and then the total. This is the cost per pound. So we know that the blackberry tea costs $25. What else do we know? Next we know dried blackberries cost $10.50. So put that in, put in everything we know. We know the black tea costs 35 per pound. All right, now question is how many pounds of black tea? So we'll put in a variable, how many pounds of black tea? That's what we're looking for. Should be added to 5 pounds of dried blackberries. So we put our 5 pounds right there to make blackberry tea. Now this is the key right here to mixture problems, how to set this up. To figure out what goes in the blackberry tea, we have the 5 pounds plus the W. Okay, 5 pounds plus the W. And then we can figure out the total cost. The cost here, we have 5 times the 10.50, and then W times 35W, and here we have to do 5 plus W times the 25. Okay, evaluate this. We get 52.5. Do distributive property, 25 times 5 and 25 times W. We get 125 plus 25W. Now, in this column right here, I can set up an equation. I know that this, the cost, total cost of the dried blackberries, plus the total cost of the blackberry tea is going to equal the total for the blackberry tea. So I'll set that up as an equation. 52.5 plus the 35W is equal to 125 plus 25W. Let that part sink in. Setting up is usually the hardest part of this. Now solve the way we've been solving. Variable on each side. Subtract one of the variables. I recommend the smaller one. And then solve for the variable. Get it by itself. 10W, divide by 10 on each side, and we get W, which, what was W? W was how much black tea we wanted. Okay, so we need 7 pounds and 7.25 pounds. All right, here's another problem. I'll go through this fairly quickly. We have 16 cups of punch, 3% pineapple. Also have a punch with 33% pineapple juice. How many cups of the 33 punch do we need to add to 3% to get a 20% pineapple juice? All right, here's our columns. We have the amount right here. We have 16 cups of the 33% punch. The question is how many do we need of this? And together, that would be the 16 plus the X to fill up my 20% punch. Now I have the total. Here is 0.3, 3% times the 16 is 0.3. And then 33 times X is 0.33. And then 20% times the 16 plus X. Now, this is a 3-column, okay? This is the first column. This is the percentage. Okay, it's a little confusing because they've given this the name 3% punch, but this is also one of the columns right here that you know. Okay, so then again we set up our equation, we multiply distributive property. Here set up our equation, eliminate one of the variables, solve for the variable by subtracting, and divide, and we find out we need 20.9 cups. Okay. And that is mixture problems for you, ladies and gentlemen.